Hey guys, real quick battery teardown video here for you today. I have a DynoEurope. This is a 12.8 volt 120 amp hour lithium iron phosphate battery. I purchased this from Battery Hookup nearly 3 years ago. If you're not familiar with Battery Hookup, they are a recycling center, a battery recycling center that breaks down and resells batteries, hopefully for repurposing, cell reclamation, things like that. I purchased this during a time when I was still using cobalt-based chemistries, and I knew I wanted to move away from them, but the price of new LFP batteries just wasn't there yet for me. So I was still in the mindset of trying to reclaim and scavenge used cells to build battery packs. That's where this came into play. I purchased it. The invoice, I think, was dated December of 2021. It was right around the time the prices of new LFP batteries was really starting to come down. And because of that, I ended up just not doing anything with this battery, and I went and purchased the EVE LFP 280 cells for my initial build. Ever since then, this battery has been sitting under my bench. There's a little green LED on here that blinks from time to time. It's been blinking for about 3 years now. I'd really like to not have it sitting under my bench, but before I either take it to the recycler or give it away, might as well tear it down since we already paid for it, and we'll see what's inside. This is a fairly different battery. As you can see, it's got these balance leads on the front here, and I can't actually find much about these batteries online other than this company seems to specialize in battery packs for, larger equipment, whether it be like forklifts or trucks or things like that. So I suspect that this is designed to be used in a configuration greater than a typical 48 volt battery bank. So there was one specification sheet that I found online here, and you can see in the top right the LIT module. That is the master BMS, which is going to communicate to the individual batteries through these cables. So you would wire these BMS cables in series essentially, and I assume it's probably a basic CAN or Modbus type communication in there, I'm not sure. But they all communicate back to that master controller. And then if you look on the bottom right of the specification sheet, we have model number LIT-D12-120M+. And it says it's a 12.8 volt battery, 120 amp hours, and you can see a few other specifications about it there. Now, because I purchased this battery used, I can't remember what it was being sold at. I'm thinking it was probably like 85 or 90%. In addition to having it sit under my bench for 3 years, I'm not going to bother the capacity test. I don't see a point in doing that. I just want to tear it apart and see what's inside. It is just like an odd feeling battery compared to some of the others we've looked at. It feels a lot more solid and heavy and more dense, I guess I would say. So I suspect there may be cylindrical cells in here. I don't know that it's going to be aluminum case prismatic cells. But before we get into that, on the note of batteries, I did start a new web page I'm kind of experimenting with. It's listing out all of the lithium iron phosphate batteries I could find on Amazon in an effort to find the listings with the cheapest battery. So you can check that page out at batteryfinder.net. You can filter it by voltage and by capacity, and then it sorts by price. You can sort by brand. There's hundreds of listings out there, and the idea is I want to be able to pull up a simple page and see what the cheapest battery is at the time. You would think that'd be something easy you can do on Amazon, but it's really not because of the way Amazon filters and curates their listings. And I'm hoping this will come into play around Black Friday as we start seeing some deals, so we can see those deals reflected on the Battery Finder website to quickly say, okay, here's the best battery. It's certainly not batteries I'm endorsing. A lot of the brand names are just gibberish. But it's just hopefully a quick way to find the cheapest deals out there. Just grabbing a quick weight before we do that, this battery is at 33 pounds and 14 ounces, so it's pretty much 34 pounds. Here's a quick look at the communications connectors. It's just a 5-pin male and female. It's a locking connector with a twist. It does have some rubber material in there, so I assume it's moisture resistant at least. There's a large series of Phillips screws around here to pop this panel out where I assume part of the balancing board is. We're going to go ahead and remove that. So we can start with the two communications cables. They come down to these left two connectors here. We have a 2-pin with a red and black. That might be 12 volt power for the board, just guessing. I'm not sure what this is. I'm not sure what this big long one is here. Maybe temperature sensors? And then I believe this connector here with the 5 pins is going to be for the balance leads. I did notice this balancing board is dated 2016. It looks like May 21st of 2016 there. Taking a look at the bottom of the board, the area where I thought the balance leads were are labeled V0 through V6, so those may in fact be the balancing leads. And then I see the black cables are labeled RT4 through RT17. Assume those are going to be temperature sensors. I don't really know much more about what I'm looking at here. One thing I did notice though is that the negative lead of the battery obviously does not run through the BMS. There's no connector for it and there are no FET transistors on here. So I suspect this battery cannot shut itself off and is likely controlled by that master controller controlling a contactor or something else further downstream. I don't really see any other way to open this battery. In the past I've used screwdrivers or putty knives and just chiseled it apart, but this thing just feels a lot more solid than usual. I did pick up one of these oscillating tools here. It was on clearance. It was on clearance, so it was pretty cheap, and it got me an additional 18-volt battery pack along with a charger. And I've seen certain other YouTubers open batteries with this particular tool, so I'm just gonna give it a try for fun here and see how it works out. Before I do that, I need to go get my safety gear first. That certainly got me a good start there, but I really don't like plunging a tool like that into batteries, not knowing what's on the other side. I can kind of see what's in there now. It is cylindrical cells. Look at that. Look at the number of washers they have on these terminal bolts. There are 4 washers, 4 washers, presumably stainless steel, and then a 5th lock ring. That's a lot more washers than I've ever seen on an actual power terminal like that, but man, that almost looks like it's a shunt. Is that a shunt? That's actually a shunt. It's got a shunt in there. And unfortunately, I've bent it and ruined it. I've never seen a shunt in a battery pack before, and it says 300 amp and 45 millivolts. So it's a 45 millivolt drop shunt. And one side is the terminal there, and the other side has your 2 leads. So that was the connector that had a red and a black lead, was the shunt measuring. And you can even see the notches they cut in it for calibration purposes there. So that is very cool. That's going to be a nice hunk of brass for the scrap bin. I did drop off probably 3 or 4 years worth of scrap metal at the scrap yard the other day, and I got like 700 bucks for it. So I'm definitely saving, you know, all of the scrap metal out of these batteries. All right, so we've got welded copper bus bars. Look at that. I'm not sure the whole thing is copper because I do see some silver down in there, so maybe there's something else, nickel. Maybe it's a copper sheet on top of nickel, which we have seen before, sort of a sandwich approach. The whole thing is enclosed in this rubber padding, so it's rubber padded on all sides, and those are, I do believe those are 18650 cells, so that is a lot of 18650 cells. It's kind of unfortunate if you ask my opinion because I am just I'm over 18650 cells at this point, so I would have preferred not to see those, to be completely honest, but it is what it is. Underneath the rubber where all the cabling was, we have a number of temperature sensors. You can see these are actually nice heavy-duty temperature sensors here. It's not cheap wiring by any means. The balance leads are actually spade terminals, so you can remove and reconnect them. That's the first time I've seen spade terminals in a battery. And now we have a complete undamaged wiring harness. Certainly don't need it, but the fact that you can disassemble and service something like this is very cool. Alright guys, so I've hardly done anything aside from pulling off the rubber and tape, and this cell literally just fell out in my hand. It just fell out. And it is spot welded. There are two spot welds on the positive side and there's 4 on the negative, but man, they are weak for sure. And it just rolled right out into my hand. So any of these others are loose, or I don't know what the deal was with that one. None of the other ones feel loose. They're all in there pretty tight. So perhaps there was a known defect with this battery and that's why it was recycled. Let's go ahead and unhinge this battery, and what I mean by that is the way it's built has hinges. Look at that. All right, and what's interesting too is I noticed over here appears to be an impression of the palm of someone's hand. I don't know if it's a palm or it's part of their hand for sure. Some sort of dirt or corrosion from oils on their skin, I don't know what, but the welds on the cell do look very, very weak from the spot welds I've seen before and the spot welds I've done before. And then we have this one here where it looks like somebody like blew a hole through one of the pads. I don't know, this one here has a hole blown in the welding pad too, and it looks like it's actually damaged part of the cell. So I'm surprised to see. This is the space up here where that cell fell out of, and I do see there are 4 weld marks on it, so I'm not sure again what was up with that. I did try to pry one of these other ones, and it's on there pretty good. It's not just like popping off or anything. So this is a 12-volt battery. As you probably would have guessed, there are 4 packs of cells here. These cells are very generic cells. PSR is likely the brand or the manufacturer. The model number is LFP18650E. 3.2 volts, and they are 1500 milliamp hours per cell. There are 79 cells in each pack. 79 times 1.5 gives us 118.5 amp hours. I counted them twice. There are 79 cells per pack. So these cells do fall out fairly easily. I just heard one crack here while I was bending this back just a little bit. And I mean, I had to pull the negative a little bit, but man, the positive just popped right off. Yep, see? That just popped right out. That's not very good spot welding in my opinion, but of course I am not a professional here. Alright guys, that's pretty much it. It was interesting to see something different for a change as opposed to the, same batteries we open with the same cells and the same BMS over and over again. So while I don't like 18650s, I do appreciate seeing something different. If you have any questions or comments, feel free to leave those as always. If you check out the batteryfinder.net website, I'd love to hear your feedback on that tool as well. Hit that like button before you go, and thanks for watching.